Hello, Math 3. Today we're going to go over the notes for Module 3.2, Day 3. Now, on this handout, you'll notice that for each section, there is an example and then some problems to do in your notebook. You're welcome to write the examples on this paper so that you have them handy, or you may choose to write them in your notebook instead. Okay, so we're going to talk today about perfect square trinomials. And remember, a perfect square is something that can be expressed as the product of two identical factors. For example, 9 is a perfect square because it can be expressed as 3 times 3. A trinomial is a polynomial with 3 terms. It's a polynomial with 3 terms. Okay, so it asks us to factor using big X. Notice there's no equal sign. That means that when we're done, our answer is just going to be these things that are called factors. So we'll set up big X, A times C on top, which is 25, B on the bottom, which is 10. We need two numbers that multiply together to be 25 and add up to be 10. Well, since we're talking about perfect squares, we can probably guess that we could square root 25. We'll get 5 and 5. And what we have here is x plus 5, x plus 5. Now we can stop here because the directions say factor, and there was no equal sign in the original problem. So that's what you're going to do for B, C, and D. And I'll show those here in case you're somebody who doesn't have the worksheet. You could pause and copy these down. Okay, you are supposed to create formulas for number 2. I believe we already did this on the previous page. So we can rewrite these, and if we rewrite these, they would look like this. And notice this is a perfect square trinomial because it can be expressed with two identical factors. Just like these two factors are identical, so this is a perfect square trinomial. Just like these two factors are identical, so 9 is a perfect square. Okay, so make sure you have these formulas and that you add these to your list. And again, we call these, as you see it, we call these perfect square trinomials. It's the name of the pattern. Okay, so now we're going to use the formulas to factor these. So instead of big X, we're going to use one of these two formulas. Well, I notice it has a plus here, so I'm using this formula. And the first thing I need to do is identify A and B. So A squared is the same thing here as X squared, and B squared is the same thing as 3 squared. So that's my A and B. I should also just check, is the middle 2 times A times B? And it is. That equals 6x. So that means I'm good to go. This is x plus 3, x plus 3, because there's my A, there's my B, and that's the same as x plus 3 squared. And you'll notice I got the B by taking the square root of this last term. I got the A by taking the square root of the first term. Okay, now let's talk about using the identities to to solve. So it says solve by using a factoring shortcut and zero product property. So instead of using big X here or quadratic formula, I'm going to just factor straight away. I can see that this is 121, which is a perfect square, x squared, and I'm pretty sure that this is x minus 11, because 11 times 2 is 22, so we're good. equals 0, right? Equals 0 equals 0. And then I would have to set my factors equal to 0. X minus 11 equals 0. I mean, I could write it again, but I don't really have to. Then I add 11 to both sides. We've solved lots of problems like that. So we are saying if x equals 11, if I put 11 into this equation, then this equation on the left would equal 0. Okay, so x equals 11 is a solution. We have solved the equation. Ooh, this is not a perfect square trinomial. This is difference of two squares, right? So I could say that my a would be 3x, and my b would be 2. So I can use the a minus b, a plus b shortcut. So 3x minus 2, 3x plus 2 equals 0. So I have now factored, and I set my factors equal to 0. Zero product property says if one of these factors equals 0, then the whole thing equals 0. So I'm going to set each factor equal to 0. And then I'm going to perform my inverse operation. Divide both sides by 3. And x equals positive 2/3. And then on the other side, I'll do this one a little faster. So I have my two solutions. If I take 2/3 and I plug it in here, then the left side of the equation will equal 0. If I stick negative 2/3 in here, the left side of the equation will equal 0. So these are my solutions. So notice here, we had one with a perfect trinomial square and one that used difference of squares. Okay, now number 5, we have a little bit of a flashback. It says solve using the square root method. And when we use the square root method, what we're going to do is we're going to isolate x for square root method. So if we want to isolate the x, let me rewrite this problem here so I have a little room to work. If we're going to isolate x, I'm going to use my reverse order of operations. So for these, I'm going to use SADMAP. Outside of the parentheses, there's nothing added or subtracted. There's nothing multiplied outside the parentheses, so that means I am on the E for exponent. I have to get rid of the exponent, and the way I'm going to do that is I'm going to square root both sides. If you square root a variable, you must put a plus or minus on the other side, but since it's a 0, the plus and minus don't really matter. Okay, so now when I do this, it crosses off my square. So that's outstanding. That's what I wanted. And I get x plus 11 equals square root of 0 is 0. And now I'm going to finish solving. Minus 11, x equals negative 11. So that means that if I plug in a negative 11 to this equation, I will get 0. Okay, let's solve this one using the square root method. Is there anything subtracted or added to the x? There is. So I have to get rid of that first. So I'm going to add 169 to both sides. Remember, our goal here is to isolate x. There's nothing divided or multiplied by the x, but there is an exponent. So now I'm going to square root the x squared. And then I'm going to square root the 169 with a plus and minus. Square root of x squared is x. Plus and minus square root of 169 is plus or minus 13. So those are my solutions. And what that means is if I put a positive 13 into this equation, that this side will equal this side, which means that it will equal 0. That works. 13 squared is 169 minus 169 equals 0. Negative 13 times negative 13 is also 169 minus 169 equals 0. So I got it. Okay, let's look at letter C. We're supposed to use the square root method. So you know what that tells me? This must be a perfect square. So what squared equals this? Square root of x, square root of 49, 7, negative sign. Then I just have to make sure that the middle works out. Is 2 times x times negative 7 negative 14? Yes. And now the solving is just like the first one. So I'm going to do a square root of x minus 7 squared, which is going to cross off my square. I'm going to do a plus and minus square root of the other side. But since it's 0, there is no positive and negative 0, so it doesn't really matter. And I get x minus 7 equals 0. I add 7 to both sides. X equals 7. If I plug a 7 back into this equation, because 7 is a solution, it will make the equation true. It will make this side equal this side. Okay. There's a few more here to do on the second page. Part 3, factoring out a greatest common factor. So when we factor out a greatest common factor, it's a little bit like simplifying. And it does say to check our answer by distribution. Notice there's no equal sign, so we're not solving anything. We're just factoring out. So we have to ask ourselves, what number can divide by 10? Or 10 can divide by this number, and 14 can divide by this number. Another way to think of it is, what times table has an answer of 10? What times table has an answer of 14? And what do they have in common? Well, they both can be divided by 2, right? 2 times 5 is 10. 2 times 7 is 14. So I'm going to factor out a 2. In other words, I'm going to put a 2 outside. Also, this one has x to the 5th power. This one has x to the 2nd power. If every term has a variable, then you can factor out the smallest degree variable. So you can think of this like this guy is carrying around 5 x's in his pocket. This guy's carrying around 2 x's in his pocket. So the most we could, quote, steal from both of them, if we were going to steal an even amount, would be x squared. And so now this is like that reverse distribution process we've talked about before. 2 times 5 is 10. What would I have to multiply by x squared to get x to the 5th? Well, that would be x to the 3rd. Or you can think of 5 minus 2 is 3. 14 divided by 2 is 7. And I factored out the x squared. So that is my answer. And it did say I was supposed to distribute to check my work. So I'm going to rewrite this, and then I'm going to distribute to check. Two x squared times 5x cubed is 2 times 5 is 10. X to the power of 2 times x to the power of 3. You add your exponents. That's x to the power of 5. 2 times negative 7 is negative 14. There are no x's here, so that x squared becomes a part of that term. And that matches my original. So for all of these, all you're doing is factoring out a greatest common factor. Okay, you don't have to do any special big X, any identities, just factor out a greatest common factor. So it should be like one step. And then you're going to check by distributing. Okay, because now on part 7, now it says factor out the greatest common factor and then continue your factoring using an identity. Okay, so here I have a 2 and a 32. Well, lots of things go into 32, but your greatest common factor can't be smaller than the smallest coefficient. So I can factor out a 2. I can't factor out any x's because if both terms don't have x's, you can't factor out x's. So that gets me x squared, and 32 divided by 2 is 16. All right, and I can do this one in my head. If I distributed, I'd have 2x squared minus 16 minus 32. I checked it, it's good. I should have another identity, right? And I do. This identity is difference of squares or difference of two squares. Some people call it DOS, some people call it dots. So I'm going to keep my 2, that's very important. And then I'm going to factor this into x minus 4, x plus 4. And what's important is all of these expressions are equal. I like writing mine underneath each other, but in your notebook, if you'd like to write it straight across, you could do that also. By the way, that reminds me here, I should have had equal signs, I forgot. Okay, that's it. This is what we call the most factored form of that one. Okay, one more part, number 8. Factor out a greatest common factor, and then factor the resulting quadratic using big X or special big X. Okay, the greatest common factor, what I usually check for, first of all, is the smallest coefficient, 18, 33, 9. Okay, can I factor out a 9? 9 times 2 is 18, so that'd work. 9 does not go into 33, so I cannot factor out a 9. So what's another number? Well, you know what? 33 is literally only 3 times 11, so I can't factor out an 11. I can factor out a 3. I'll take my smallest exponent of x, so 3x squared. And now 3 times what equals 18? That's 6. You can subtract exponents if you want, x to the power of 2. If I double check that, 3 times 6 is 18, x squared times x squared is x to the 4th. Minus sign, 33 divided by 3 is 11. If I want to subtract exponents, I can. X to the 3rd divided by x squared is x, or x to the 1st. 9 divided by 3 is 3. Then I always want to check and multiply this back out. 3 times 6, 18, x squared times x squared, 18 to the power of x power 4. 3 times negative 11, negative 33, x squared times x to the power 3. Good. And I got a quadratic, which is what I expected because it said factor the resulting quadratic. And if you remember, a quadratic is a polynomial with a degree of 2. That means the biggest exponent is a 2. So at first, this wasn't a quadratic, but when I look here, it is what's inside the parentheses now is a quadratic. So I'm going to go to the side to do, this is going to be a special big X problem. So A times C would be 18. I have a negative 11 on the bottom. So I want two factors of 18 that add up to be negative 11. It's negative 9, negative 2. Now I'm on that bring down step. So I have 6x squared. Then I bring down 9x. I bring down negative 2x. I'm so sorry I covered that up. The bring down step, I bring down 6x squared. Notice I'm using this one now. I'm not looking at the beginning. Bring down negative 9x, bring down negative 2x, and then I got to bring down plus 3. This 3x squared is still here, but I'm going to leave it up here for a minute just so it's not in my way. And now I factor out greatest common factor here. Between 6 and 9, that's 3 and an x. 6 divided by 3 is 2. 2x minus 3. Remember, we bring down this sign exactly. 2x plus 3 do not have a common factor other than 1. And look, that's a negative 1, so it'll be 2x minus 3. And now I put the outsiders together. This 3x minus 1 becomes a binomial. 2x minus 3 becomes a binomial. And I can't forget that I had this 3x squared. So what I'm saying is if I multiply all these back together, I would get back to what I had at the beginning. Okay, not all of these will be special big X. Remember, if A equals 1, you can do this big X, write the factors, you're done. If A is not 1, then you have to do the special big X. So this is a good example to remind you how special big X works. And just to emphasize, if you wonder where I got these numbers, I got the 6x squared from right here. I got the plus 3 from right here. I changed the negative 11x into negative 9 and negative 2x and put those here. Okay, I hope this has been helpful and that you're ready to do the assignment. I also really hope it recorded because I don't want to do this all again. Oh, bye.